In this video, we're going to continue looking at the definition of derivative. Example 5 wants us to use the derivative that we found in problem number 4 to answer the following questions. So looking at problem 4, we found that the derivative for 8x minus 2x squared was 8 minus 4x. So let's write that down here. Using our notation for derivative, we would write f prime of x equals 8 minus 4x. Now it wants us to find the slope. Now remember, we said above that the derivative is the same as the slope. Let's remember that. Here we wrote it. The derivative is the same as the slope of the tangent line, instantaneous rate of change, and velocity. So back here, when we want to find the slope of the graph, we're just going to plug those values into our derivative. So the slope at 1 would be f prime of 1, which would be 8 minus 4 times 1, or 4. The slope at x equals 2 would be f prime of 2. So 8 minus 4 times 2, or 0. And the slope at 4 would be the same as the derivative of 4. So 8 minus 4 times 4, which is 8 minus 16, or a negative 8. Part B wants us to represent that on a graph. So we have the graph here of 8 minus 2x squared, and we want to make a rough sketch of the line tangent to the graph at 1, 2, and 4. So let's try to draw those lines in. Here I've tried to graph the point at the line that would be the tangent at x equals 1. So here's x equals 1. I tried to draw a line there. And if you remember from our calculations, we found that slope to be 4. Well, if we take this and we look at from 2 points, one to the next, we can see we're going up 4 and over 1. So at 1, we do indeed have a slope at 4. Then they want us to find the tangent line at x equals 2. So here's where x is 2. There's our function value. And that line would be the horizontal line, y equals 0. So again, we do have a slope of 0. And then at 4, we're going to try and draw a line here. So I'm going to pause and get some help with that. So for this problem here, I've attempted to draw the line when x is 4. You can see that has a very negative slope to it. And if we count from point to point, it's going over 1, but down 8. So that would be a negative 8 slope, which is what we got. Let's try example 6. In example 6, they want us to find the derivative for f of x equals 1 plus x over 2. So let's put that formula on here. So the definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. First step is to find what f of x plus h is, which means we're going to take this, and wherever we see an x, we're going to substitute in x plus h. So f of x plus h is going to be 1 over x plus h plus 2. And then our f of x here is simply the 1 over x plus 2. So if we rewrite this with those values put in here, we'll have the limit as h approaches 0 of 1 over x plus h plus 2 minus 1 over x plus 2 over h. Well, we can't cancel the h's as they are now, so what we have to do is get a common denominator for our fractions in the numerator. In this case, since they are different and don't have any factors in common, the common denominator will be found by multiplying these two denominators together. So that'll look like this. The first fraction will have a denominator x plus h plus 2 times x plus 2. And so will the second fraction. Now that's still in the numerator. Our real denominator for this thing, it's going to be the h down here. Now what will our new numerator be? The numerator prior just had a 1 in it. The denominator was multiplied by x plus 2. So the numerator must also be multiplied by x plus 2. So the new numerator of our first fraction will be x plus 2. My second fraction only had the denominator of x plus 2, so it was multiplied by this x plus h plus 2. So my new numerator here will be x plus h plus 2. Now we have to try to combine those numerators. 0. So in my first numerator, I have x plus 2. And from that, I'm subtracting x plus h plus 2. So this negative will be distributed to all three of those terms and will give me a minus x, a minus h, and a minus 2 over that common denominator. All over that h. Now in our upper numerator, the x's cancel and the 2's cancel, leave me just with an h. I'm sorry, it leaves me just with an h, not an x, because the x's cancel, the 2's cancel, and we're left with a negative h. It's over h. Now, what you learned long ago when you divide fractions is you take that top fraction and you multiply it by the reciprocal of the denominator. Let me write this out. My top fraction is negative h over the x plus h plus 2 times x plus 2, and that's being divided by h. The way we learn to divide fractions is to flip this second fraction and multiply. So instead of writing divided by h over 1, we're going to write times 1 over h. This is good because then our h's cancel here. And what we're left with is a negative 1 over x plus h plus 2 times x plus 2. But recall, for this problem, we really want the limit of this as h approaches 0. So we want the limit of negative 1 over this. Well, if h approaches 0, then this part of my denominator is really x plus 2, because x plus 0 plus 2 is x plus 2, and it's being multiplied by x plus 2. So when we simplify this and h approaches 0, we get a negative 1 over x plus 2 squared. And that is the derivative of this. All right, thanks for watching. In our next video, we will take a couple more derivatives.